Okay, we are on page 340, lesson 7.1. We are solving systems of equations by graphing. Example 1. We are going to graph these two lines and we're going to find their solution. Their solution will be the point where they cross each other. So the first thing you need to do is you need to draw yourself a set of coordinate grid on your paper. This is my x-axis, this is my y-axis. Okay, so I'm going to graph here. The first one, it's not going to work for me. I'm going to use pink. First one I'm going to use pink. I'm going to sharpen the pencil. Okay. What do I start with on that graph? Where do I begin? When you're asked to graph, where do you begin? Where do you begin? -3, because -3 is the y-intercept. So put a dot right there. And then what do? You apply the slope. What's the slope in this problem? 2/1 is the slope. And that's driving directions. It tells you where to go from the y-intercept. So you go up 2 and over 1. Okay. Take something straight. Connect that line. Okay. Now, we'll graph this one. Where do we start? -1. What's the slope? 1/1. There's nothing in front of that x, so you know there's a 1 there. You know that slope has to have two parts because it's a rise and a run. So from that y-intercept, you will go up 1 and over 1. And that will be your second dot. And you will connect them. Now the whole objective for today is to find out where the lines cross each other. Do these two lines cross each other on your grid? Is it visible to you? Because sometimes we'll draw and they will appear to eventually meet, but we may not have them extended long enough. Have we extended these long enough so that they cross? Okay. Can you tell me the name of the location where that happens? It happens right there at 2, 1. That is the solution to the system.
It happened at 2, 3 for me.
Okay.
It happened at 2, 3 for me.
Really? Well, you might have gotten off a little bit on your grid. I'll look at it in a minute. Be very careful as you're graphing today, and listen to me. As you're graphing, they're going to get close. They're going to get close. Sometimes they're not going to be exactly on that crosshair. You're going to have to, because we're human. When we graph them, sometimes they're just not going to be perfect. But you need to give me the best answer you can. Now, let's go back and let's talk about what this means. 2 is in the position of x and 1 is in the position of y. What this means is if you put these values in the pink equation, they will work. And if you put those values in the green equation, they will also work. Let me show you. For the first one, it says y equals 2x minus 3. I'm going to use these values for x and y. 2 times 2 minus 3. I'm checking to see. I'm proving this to you here. 2 times 2 is 4, and 4 minus 3 is 1. So did they work? Yes, they worked for that equation. Let's look for the next equation. Y is 1, x is 2, so this is 1, so do these work? Yes. That's what a solution will do. That is the only point. 2, 1 is the only point that makes both of them true at the same time. I could use the point 0, negative 3, and it would make the pink line true, but not the green. I could use the point 0, 1, or 1, 0, right here, 1, 0, and it would make the green line true, but not the pink. Okay? So we are looking for that one specific spot that makes both true at the same time. If you look at the graph, it's the place where they cross each other. If you look at the equations, they'll make both equations true at the very same time. If you're making a table, and you let y1 be the pink and y2 be the green, then when you have a 2 in place of x, both of those will have a 1. If you had a 1 in place of x, if you put 1 in place of x in the pink equation, what would you get for y? Negative 1. If you put 1 in place of the x in the green equation, what would you get? 0. See, they're not the same right here. So you're looking for the spot where they're the same. You're looking for this. You're going to be graphing and looking for the spot where they cross. Let's do another example. Y equals x plus 5 and y equals negative 4x. Let's do this example. Okay, I'm going to graph this one. Where do I start? At 5. And my slope is, so I go up 1 over 1. There's my pink line. Okay, green line. Where does this start? Where? 0. And what is my slope? Down 4 over 1. Where does it appear that these two cross each other? Negative 1, 4. Can you do this? Can you graph these lines and tell me where they cross? You're probably going to need a ruler or maybe a sheet of paper or a book for a straight edge. Anything that's straight. Don't get in trouble with a ruler. Okay, let's look at another example. It says y equals negative 2x minus 1 and y equals negative 2x plus 1. This is example 2.
When you get your answer, would the first number be x or y?
X. Okay, let's do this first one. Where do we start? negative 1. Is everybody ready? Put a dot at negative 1. What is the slope? Negative 2 over 1. So go down 2 and over 1. Does everybody have this line drawn? Let's do the next one. Where do you start on the green one? 1. And what's the slope? So I go negative 2 over 1, so I go down 2 over 1. What do you think about this pair of lines? This pair is parallel. Are they going to touch? No. There is no solution because there's not a spot where they touch. If they're parallel, they're not going to touch. They're parallel. How do you know? I mean, we're going to graph them. Y'all, we're human. Our graphs are not perfect. But there's another way you can look at these two lines and know that they're parallel. Their slopes are the same and their y-intercepts are different. Their slopes are the same and their y-intercepts are different. So we know they're parallel by inspection of the equation. And then we verify it when we graph it. Okay? So if you get one that's parallel, it's a no solution. Example 3. Example 3. It says 2x plus 4y equals 8 and y equals negative 1/2 x plus 2. One of these equations is ready for you to graph. Everything is visible. The y-intercept, the slope, it's ready to go. The other equation requires you to do some work. What do you need to do that first equation before you can graph it? You got to get y by itself. And the first step in getting y by itself is to, who can tell me? Subtract 2x. So it says 4y equals negative 2x plus 8. I'm not completely done. What else do I have to do? And divide every single part by 4. Okay? Every single part. So this says y equals, it says negative 2 over 4. Can I write that in a simpler way? Negative 1/2 plus, what's 8 over 4? 2. Okay, so now I'm ready to graph. Okay, let's start with the pink equation. Where do we start? 2. And what's the slope? Negative 1 over 2, so you go down 1 and over 2. Okay. Now we're ready for the green. Where do you start on the green? 2? Oh, okay. Well, guess what? I figured out that's a point they have in common, right? That's a point they have in common. Sometimes the y-intercept is where they meet. What's the slope? Down 1 over 2. Oh, they have another point in common. And then what happens when I draw the line? They are the same line. They are the same line. Well, then how many points do they have in common? Everything. Every single point that's on the pink line is also on the green line. Every single point. So when that happens, you have infinitely many solutions. Okay? Infinitely many solutions. So there's three things that can happen. I can graph these lines and they can cross, and then I'm supposed to say they cross at such and such. Or I can graph these lines and they're parallel and they never touch and I have no solution. Or I can graph these lines and they are the same line and they have infinitely many solutions. Those are the three things that can happen. There's not going to be any other situation. They're going to be infinitely many, no solution, or you're going to get an answer. Okay? So for today, page 343, 1 through 22, all. 1 through 22 all. I'm going to work number 1 with you. Number 1 is not a graphing problem, so I'm going to work it with you. I want to be sure you understand what I'm asking for. I know when it says graph, you know what to do. Here we go.
343. Like guilty squad 343 from Halo.
Okay, here we go. Question 1 says, x plus y equals 4. X equals negative 1. Is negative 1, 5 a solution? I know you don't know what that means, so we're going to talk about what that means. I want you to understand before you get out of here what that means. If negative 1, 5 is a solution, then if you plug the values from that ordered pair into the equation, it will cause the left side to equal the right side. They will be equal. So let's test it in that first equation. X needs to be replaced with the x value from the ordered pair. And what is the x value from the ordered pair?
Slope. The first number is y and the second number is x.
Slope is
I
slope.
can't tell what the heck, which one's which.
Okay, slope is different than ordered pairs, okay? Look at the slope chart back there. You're exactly right, y over x. But when I'm dealing with ordered pairs, look right here. Ordered pairs always comes this way, x, y. They're different. So what's the x value here? So this is negative 1 plus, what's the y value? 5. Is that equal to 4? Yes. So I get 1 yes. I got to get 2 yeses for the whole thing to be yes. The next equation only has one letter, which is x. Replace that x with its value. What's its value? So negative 1 equals negative 1. Is that true? Yes. So the answer to the whole problem is yes. Okay? What kind of line would say x equals negative 1? What kind of line would that be? It would be a vertical line running through where x is negative 1. It'd run right through here. That's what that would look like if you graphed it when it says x equals negative 1. Okay. I'm going to be quiet and let y'all work.